In this lecture, we will look at how the defect sites on the electrode surface affects the microstructure of the electrodeposit. So there are many factors that affect the morphology or the microstructure of the electrodeposit. One of the major influence is the rate of electrodeposition. Okay, so the microstructure or morphology is very different when the electrodeposition is conducted at low rates or at high rates. Okay, so typically you can control electrodeposition rates by controlling the O potential involved in electrodeposition. This has a dominant effect in the morphology of the electrodeposit. So you can also have additives in the electrolyte. These have influence on surface energy of the electrodeposit and so on. They also have an influence on the morphology of the electrodeposit. We'll elaborate these issues in later lectures. So this is supposed to be a broad introduction to the microstructure. So what we'll be focusing in this lecture is on this aspect. There are different kinds of defects on the electrode surface. They have an influence on morphology. That is going to be the focus of this lecture. So this has a lot of descriptive information. So we will go over this information and processes described here in the next few slides. So what are we seeing here? So we are looking at an electrode surface with different structural features. So the different structural features indicated here are the electrode surface may have vacancy. So this is a missing atom on a flat surface. The electrode surface can have predominantly flat surfaces. So that is indicated here. Or it may have step edges, which is indicated here. Or you may have so-called kink sites. Okay, so these are kink sites. Okay, these corner sites are kink sites. Kink sites. So these structural features, okay, either the flat surface or the vacancy sites or the kink site, are the different sites wherein the metal atom in this case gets deposited, electrodeposited. So there are ions in solution. These are usually solvated, and they may get adsorbed onto the surface, so that these adsorbed ions are indicated as anions. And they are then cathodically, when under sufficient cathodic potential, electrons are added to the adsorbed ions, and atoms can be deposited onto the surface. So there is some transport processes associated in the transport of ions to the electrode surface. So there can be two kinds of transfer. Most of the electron transfer occurs over the flat surface. Okay, so the transfer of the ion can be onto the flat surface, and then an ion can get reduced on the flat surface. They may diffuse and attach itself to the kink atom. Okay, so or the ions can directly get transferred to the kink site and can get reduced, cathodically reduced at that site. So what is that we are trying to explore? So there are different possibilities for the addition of cathodically reduced ions. So the ion can get added onto the vacancy site, in which case the vacancy is quenched. Okay, so there was a vacancy. There is a vacancy of one atom was missing in this site. When an atom gets added and cathodically reduced onto this site, vacancy is quenched. Okay? The vacancy is no longer present. However, unlike this process, when an atom gets added to the kink site, a new kink site is generated. Okay, so it is not that the kink site is exhausted. Okay, unlike a vacancy site, I mean, which when an atom is added, the vacancy site was exhausted, was quenched. Unlike that possibility, here an atom when added to the kink site generates a new kink site. Okay, so this has consequence in the deposition. Supposing the deposition is initiated in kink site, often this happens because the atom will get added to the site where the surface energy is higher, okay, compared to the flat region. The surface energy of the kink site is greater. Okay, so the surface energy is correlated to bond unsaturation. Wherever the bond unsaturation is higher, the surface energy is also higher. So amongst all these sites, there is the flat site, kink site, vacancy site. The flat site has relatively less surface energy. Okay, so or less under coordination. Therefore, its surface energy is lesser. The kink site has greater surface energy compared to, let's say, the flat surface or step edges. So there's a greater chance electrodeposition is initiated at the kink site. If the electrodeposition is initiated at the kink site, a new kink site is also generated. Okay, so the electrodeposition may continue along the kink site itself. Okay, so this has a characteristic feature. So the electrodeposition initiated at the kink site can be further sustained by kink site. So it continues to grow along the kinks, and this generates a particular kind of a morphology. So this morphology is usually seen when the electrodeposition is conducted at low O potentials, and this is the characteristic morphology at low O potentials. So these pictures are obtained by microscopy, let's say electron microscopy. This is a dominant morphology at low O potential when the electrodeposition is carried at low O deposition. Unlike that case, you may also have electrodeposition at high O potential. So what did we first see? So we first saw that in the first case, what was described in the previous two slides, the electrodeposition, let's say, is conducted at low surface O potential, cathodic O potential, in which case an element that is deposited here on a flat surface or even on step edges may diffuse to this kink site, and even though it is an atom is added to the kink site, a new kink site is generated. So next atom will get added to this site. Okay, so so there are two processes here. Adsorption of an ion onto the flat surface, reduction there, and surface diffusion. Okay, so unlike this scenario, you may also electrodeposit at high O potential, in which case what happens? An ion that gets adsorbed onto the flat surface may get reduced on, and another ion can get adsorbed along this site and get reduced, and you may form a cluster. Okay, so before ion diffuses to the kink site, if another ion is deposited adjacent to this site, a cluster may grow. Okay, so this occurs typically at high cathodic O potential. Okay, so the morphology of at low potential is different from the morphology obtained at high O potential, because the morphology at low O potential is something like this. This is typically because crystal growth or electrodeposition is initiated at the kink site and sustained by a kink site. Unlike that option, you may also have electrodeposition at high surface O potential, wherein clusters may get formed and clusters may grow, and this morphology is different. So in the next lecture, we will look at aspects of nucleation in electrodeposition.